Ajay Bruno show. My guest today is Avi Loeb. He is a theoretical physicist from Harvard University who has been in the news quite a bit lately. Welcome and thanks for being with us.
Thank you for having me.
Sure. To start, could you tell us what it was that inspired you to pursue theoretical physics and study astrophysics and cosmology?
I was born on a farm in Israel and collected eggs every afternoon. And I was mostly interested, thanks to my mother, in questions in philosophy that are the most fundamental. But I had to serve in the military at age 18, as it is obligatory in Israel. And as a result, I decided to pursue physics, which was useful for the defense of the country. And I was recruited to a special program that is an elite program that allowed me to finish my PhD in physics at age 24. But during this program, I initiated a project that was funded by the Star Wars initiative that Ronald Reagan had at the time in the mid-1980s. And that was the first international project funded, and it brought me to the US to visit Washington. And in one of those visits, I also visited Princeton, and the Institute for Advanced Study. Eventually, they offered me a 5-year fellowship under the condition that I'll switch to astrophysics after I finish my military service. And I did that, and then I got to Harvard, to a position of an assistant associate professor, junior faculty, that nobody really wanted because people thought that there is no chance of being promoted to tenure. But 3 years later, I was promoted to tenure. And then a decade later, I became the longest serving chair of the astronomy department at Harvard for 9 years between 2011 and 2020. So that's a brief history of my background. And I still see myself as a farm boy. I sometimes think of going back to the farm because I love nature. I don't like so much crowds of people as much as I like. So every morning now during the pandemic, I jog in the local woods, and I enjoy the birds, the ducks, and the rabbits that run around.
I'm the same way. So you were telling me just a few minutes ago, you came here during the Reagan administration to work on SDI. Can you tell us what exactly did you do with that? And did you have any interaction at all with the president at the time?
Not with the president, but with General Abramson that led the project. He came to visit us in Israel, and I presented the project. I still have a photograph of that, and he liked it a lot. And it was a method for accelerating. We have a patent on it for accelerating masses to high speeds that could protect against ballistic missiles. And at any event, it was a long time ago, and since then, I did mostly academic work, but over the past 6 months or so, I was a member of the President's Council of Advisors in Science and Technology for the White House in Washington, D.C. So, I still see an important part of my duties to help science and technology for the nation. By now, I'm a citizen of the U.S.
Mm-hmm. Sure. So, they called it Star Wars, I guess, kind of mockingly, but it seemed to me a pretty bold idea. Do you think the concept would have been a good one if it came into fruition, or what were your thoughts on that?
Well, I think it accomplished a very important political goal of basically pressuring the Soviet Union in a way that pushed it to the limit and ended up in what we know at the end of the Cold War. And in terms of the feasibility of it, at the time it was a major threat to the US, and some physicists were cautious about the potential of actually being able to protect against those ballistic missiles in a way that was contemplated. But, there wasn't enough work done to assess whether that's feasible or not. In retrospect, I think it accomplished much more than one would have expected, politically speaking. Mm. But in terms of going to space, participated in a debate just a couple of months ago that was organized by IBM and the Bloomberg News about the question of whether the space race between the US and China is good for humanity. And all the other debaters were arguing that there is a risk to national security from going to space, and we should sign contracts with everyone, including China, and not really push this race. But it wasn't really clear to me why they're saying so, because all the military threats that might exist are from objects that are hovering just above the surface of Earth. You know, we live on a two-dimensional surface of the Earth, but space is all about the third dimension, going very far from Earth. You know, if you go to the moon or Mars or the stars, there is no military risk on Earth because it's very far away. And the whole idea of space exploration, you know, I think is the future of humanity, and something that can unify nations around this goal rather than pose threats from one nation to another. And by the way, it's not a matter of national pride, because the commercial sector is interested, Jeff Bezos and Elon Musk, and clearly there are commercial benefits to exploring space, and that's based on the global economy. It's not split by individual nations. So I think we should think more globally and consider space as one of the most exciting frontiers for the future.
Sure. I was going to bring this up later, but since you mentioned it, Elon Musk actually said recently, with his new, this fortune he has that's skyrocketing, he wants to put as much of that as possible to colonizing Mars and getting 1 million people there by 2050. What are your thoughts on that and the feasibility of it?
Well, first I should say the word colonizing is a loaded word. We don't want to use it because there are implications to what happened when, the Americas were colonized. A lot of people that used to live there died. And it's not really about colonizing, it's about opening new opportunities, on other planets. And I think the biggest concern that he's not addressing is the fact that there are cosmic rays, these very energetic particles that we are protected from because of the Earth magnetic field. So we are shielded. And if you were to go to the surface of Mars with no protection, the magnetic field there is very weak, and there is no atmosphere to protect you. Then within a year, a significant fraction of the cells in your brain and body would be damaged by these energetic particles. So one needs proper protection. You can't just go there. So either, drill caves underneath that have enough material above them to protect from cosmic rays, or build an infrastructure, a habitat that allows humans to live there for a long time. And that's a challenge that has to be addressed, can be addressed potentially, but was not addressed yet at sufficient detail. So speaking about doing it by 2050 is really dependent on whether we resolve this issue. This is a health hazard that was not contemplated, because all the trips we've made were short, to the moon or to the space station. And there is this health concern that needs to be addressed first before you send people, because that's irresponsible. It's just like pointing a gun at their head and saying you have 1 year to live. I mean, what's the point? So you need to resolve the health hazard first. And I think it's doable in principle. Any problem of that sort can be resolved by technology in principle, and we just need to consider it. But I wouldn't be as optimistic. Now, you might also worry that humans cannot really live in a completely different setting. But on that, I'm more optimistic, because humans came from Africa and learned how to live in apartment buildings, over a period of tens of thousands of years. And that's a giant leap, going from a jungle to high rises in New York City, for example. I mean, I don't see going to space as much as a leap, because you can build a habitat in space that would not be very different from the Bronx, like in principle, if you put enough money into it. So, so there are challenges on the one hand, but I do think we should address them, because currently all our eggs are in one basket here on Earth. And if a catastrophe happens, everything will be erased. So we need to contemplate contingency plans to go elsewhere. And, it's similar to the biblical story about Noah. Noah had this vision of the great flood that is about to come and decided to build an ark where he put all the animals so that he can preserve life on earth from the great flood. And, a similar thing can be thought of in terms of our future, building a Noah's spaceship that will preserve some things that we really care about. But you might think that you need to load the whales and the birds and elephants into a giant spacecraft. That's not the case, because with modern science, we can just take their DNA information and equip a CubeSat with a computer system and a 3D printer and give the information about how to make synthetic life on another planet out of the raw materials that are there using the 3D printer. So we can, with modern science, we can do much better than just loading animals onto a ship. But it's good to think about how to have multiple copies of things that we care about. Because, the revolution of the printing press by Gutenberg was that previously there were only few copies of the Bible that were all handwritten, and each of them was extremely precious. But once the printing press came along, you could produce many copies, and then you wouldn't worry about something bad happening to one of them.
That's an interesting point. I never thought of that, though, with synthetic life. But if we're just copying their DNA, they wouldn't be biological, though? So wouldn't the species not really exist in its like true form?
They could be, depending on how well we understand how to make synthetic life. So there are several laboratories around the world that are working on this, one of which is at Harvard, led by Jack Szostak. He's quite optimistic that they will get to make synthetic life. Now, it wouldn't be the same as natural life, but that's the first step. And, if we are talking decades from now or a century from now, it's quite possible that scientists will be able to produce synthetic life out of raw materials, just like you bake a cake, a complex cake, out of the ingredients in a recipe book. Same way.
Mm-hmm. So you've been in the news, speaking of life, quite a bit lately for your theory regarding Muammar. Were you surprised how much attention this has garnered?
Yeah, and I think the attention comes from the fact that, I'm trying to advocate a view that I regard as sort of down-to-earth, common sense, based on what we saw about this object. So to me, I'm not, as far as I'm concerned, I'm not trying to make any unusual statement based on all the facts that we know, okay? I couldn't really explain this object using the conventional scenarios, like if it's a comet or an asteroid, it just doesn't hold together given the evidence. So I just suggested this. Now, the only reason that I'm getting attention is because my colleagues, the other people around, behave differently, and there is a pushback. And so, I'm not responsible for their part. I can explain why I think this object is unusual and merits special attention, and why we should continue in the future. Just like walking on a beach, you see all these seashells, and every now and then you stumble over a plastic bottle that was artificially made. And the same way, when we explore the sky for objects that came into the solar system, every now and then we might encounter an artificial object. It's a message in a bottle kind of situation. And we ourselves, sent Voyager 1, Voyager 2, New Horizons. We're sending out space junk. So why should we not expect? And also I should say, half of all the sun-like stars, by now we know from the Kepler satellite that half of them have an Earth-sized planet roughly at the distance of the Earth from the sun. And so you could have liquid water on the surface and life as we know it. I mean, if you replicate the conditions on Earth, why wouldn't you get the same outcome? To me, that sounds like the most conservative assumption, to assume that under similar circumstances you get the same outcome. But somehow it's considered a fringe view by the mainstream of astronomy, and I just cannot understand why.
Mm-hmm. Yeah. So you say, you break it down in your book, that the shape, the shininess, and the way it moved are the things that really sold it to you on this being some sort of an alien object. So when you talk to your colleagues and they criticize you for it, How do you respond to that, and how do they generally react when you lay out your evidence?
Right. So my approach follows the advice that basketball coaches give to the team players. They say, look, look at the ball, not at the audience. Okay, keep your eyes on the ball. So I'm just keeping my eyes on the evidence. I don't care about how many likes I get on Twitter and what the audience is doing. That's the first principle by which I operate. But many of my colleagues look at each other before they say something. Okay, so that's first. If you want to discuss this object with me, you have to forget about the other people around you and just think about the evidence. Okay, and the point about this evidence is that this object doesn't look like anything we have seen before. Now, this is not only me saying that, it doesn't look like any comet or asteroid that we have seen before. Not a comet because we don't see a cometary tail, and the Spitzer Space Telescope looked very deeply behind this object, couldn't see any gases coming off it. Not an asteroid because there is an extra push exerted on it that you often associate with a cometary tail. So it's sort of a strange situation that there is an extra push, and we interpret that extra push from reflecting sunlight. And in fact, in September 2020, there was another object that showed a deviation from an orbit that is dictated just by gravity. And then it turned out that this object came from Earth. It's a rocket booster from the lunar lander Surveyor 2 in 1966. But before it was known that it's that lunar rocket booster, it was noticed that it deviates from an orbit dictated just by gravity without showing a cometary tail. So here is an artificial object that was hollow and thin and exhibited a push without a cometary tail. We know that it's artificial because we made it. But in the case of Oumuamua, it came from outside the solar system. We didn't make it because we couldn't even chase it with our best rocket. So it was moving too fast near Earth just for a few months. Clearly didn't come from Earth. What is it? So I'm saying, look at the facts. And there are other weird properties of this object that are described in my book. So I will not go into all of them. But, most of the criticism is coming from people that I do not regard highly as scientists, by the way. And they remind me of this congressman, that for many years made anti-gay statements. And then in March 2020, just 9 months ago, he declared that he's gay. So I would not be surprised if many of the people that make very strong statements against this hypothesis are really intrigued by it and want to believe it. So, but I should say that there are a few people that actually took seriously from the mainstream, took seriously the peculiar properties of Oumuamua and wanted, to explain them in terms of a natural process. And they had to come up with scenarios that always invoke something that we have never seen before. For example, a dust bunny. Just like you find in a household, a collection of dust particles that is 100 times less dense than air. So they imagine something the size of a football field that is a dust bunny, and it's so lightweight, it's so porous that it's pushed by reflecting sunlight. So instead of my suggestion that it may be a light sail, an artificially made object that is very thin, the argument was maybe it's a dust bunny. The problem is it will not really survive the very long journey, for millions of years through interstellar space if it's so porous, in my view. Then there was another suggestion, maybe it's a hydrogen iceberg, something that we have never seen before, an iceberg, frozen hydrogen that does evaporate when it comes close to the sun. And then you get a cometary tail, but hydrogen is invisible. It's transparent, so we can't see it. The problem with that is that hydrogen evaporates very easily. And we showed in a paper that it actually, such an object would not survive the journey. It would evaporate because of the starlight in interstellar space.
Interesting.
So, and then there was another suggestion, maybe it's a bigger object that is broken into pieces when it passes close to a star. The problem with that is only a small fraction of all the objects pass close to a star. And also, if you break them up, you will end up with fragments that are elongated, whereas the best model for the light that was reflected from these objects, the sunlight, that implied that it's flat, implied that it's pancake-like, not cigar-shaped. So you can tell, from these suggestions that even mainstream people that take seriously the peculiar properties, when they try to argue for a natural process, they have to come with something that we have never seen before. Mm-hmm. So my point is, if it's something that we have never seen before, why not put on the table also a possibility of an artificial origin? And in my mind, that origin is actually more likely than a dust bunny or a hydrogen iceberg. Mm-hmm. And that's why I say, okay, just like Sherlock Holmes, if you eliminate all other possibilities, whatever left must be the truth. That's the method by which I arrived to it. And of course, you find a lot of people that will not follow the details of the argument and just say, yeah, I don't believe this. It's never aliens. But that shows a prejudice. It's just like these philosophers that said, we know that the sun moves around the earth. They told Galileo Galilei, we know, we don't need to look through a telescope. And then they put Galileo in house arrest. But that didn't change the fact that the earth moves around the sun. And, I'm in house arrest right now, but it's because of the pandemic, not because my colleagues are putting me. Right. So in that sense, I'm more fortunate.
Yeah. So if this were an alien light sail, though, I wonder, is it unmanned? Is there no one on it? Because they seem to be just drifting through space for who knows how long. They pass an inhabited planet, but they keep on going. So what's your theory? What is this object exactly? What purpose would it have? Yeah.
Well, I think, journeys are very long at these speeds. The speed that Oumuamua was moving, it takes tens of thousands of years to just traverse from one star to the nearest star at these speeds. So it's highly unlikely that anyone would have patience to sit for tens of thousands of years on a spacecraft just to reach another star. And it's more likely to be a piece of technology that doesn't care much if you have electronics or you have just a light sail, or it could be space junk. It could be just a layer that was ripped off a spaceship or something else. And we just don't know because we didn't collect enough information about it. The astronomers basically thought that it's a comet at first. They assumed that it's just like the objects in the solar system. So either a comet or an asteroid. A comet is a rock that is covered with ice. And when it comes close to the sun, the ice evaporates and creates this cometary tail. Mm-hmm. And an asteroid doesn't have this coating of ice, so it's just a piece of rock. And they thought it's either this or that. And the data that was collected was quite limited. So we had this guest for dinner, and by the time we realized that it's weird, it's already out of the front door into the dark street. Mm-hmm. We cannot really chase it, but we can look for other peculiar objects. It's probably not the only one.
Yeah. So when do you think we'll have irrefutable evidence that there is life beyond Earth? I know the James Webb Telescope is going up later this year. So will that be what, triggers it, and they'll have to acknowledge maybe your theory was right and that there's some sort of proof they can't deny? Or what are your thoughts on that?
Yeah, so it's the James Webb, unfortunately, I was in the original science advisory committee for the James Webb a few decades ago. And the issue is that it has a very narrow field of view. It looks at a small portion of the sky at any given time. So what you need to find such objects is to cover a big chunk of the sky and just survey it for objects that are passing. Okay, That's what the Pan-STARRS telescope did in Hawaii. It was the task of Pan-STARRS was to find objects that are posing a risk to Earth. Congress in about 16 years ago decided that we need to survey the sky and find all the dangerous objects that could collide with Earth with a size above 140 meters or so. We know that the dinosaurs were killed with an object that is tens of kilometers in size, very big. It must have been spectacular for the dinosaurs to look up and see this rock coming and getting bigger and bigger and eventually smashing them. But they didn't have astronomy. They didn't have telescopes. they didn't have science, so they couldn't really protect themselves. We can notice such objects in advance and perhaps deflect them. And that was really the charter that Congress gave astronomers. And then Pan-STARRS was surveying the sky and by chance found this object, which is not really a risk, but it appeared in the image of the sky. So what you need is to survey the sky. Pan-STARRS is doing it, but within 3 years, there is another observatory, which is currently getting to completion, actually, in Chile, that is called the Vera Rubin Observatory. It's an American observatory that will have a survey of the sky called LSST that would be much more sensitive than Pan-STARRS. And if objects like Oumuamua, if Oumuamua was one out of a random population of objects that move around, you would expect to find one every month or so of this size. And that means that we should have a lot of evidence and it will start its operation within 3 years. So my hope is that once it starts operating, we will find more objects that look as peculiar as Oumuamua. And then, if one of them approaches us rather than recedes away from us when we detect it, then we can meet it halfway and just take a photograph of it. It should be relatively easy. We don't need to chase it. Oumuamua was discovered in October 2017 when it was already receding away. But if we were to discover it in July 2017, and by the way, I was visiting Maui with my family at the time and gave a talk at the observatory on Mount Haleakala, where Pan-STARRS is, and in July. But at that time, nobody knew about Oumuamua. So my hope is really that within a few years, we'll start collecting evidence about more objects that are the same. And my book serves as an alert to the community. Check out, maybe there are artificial bottles there that carry a message for us. It's another method, rather than looking for radio signals from outer space, something that was done for a while. This is another method for finding evidence for technologies that are beyond Earth.
Mm-hmm. In your book, you also mentioned a story that I heard a few months ago about biosignatures being found in the atmospheres of Venus. Do you think there's life there, or what are your beliefs on what that could be?
Well, okay, so in science in general, we should be guided by evidence, I should say, and that's a whole subject that we can discuss later, the difference between should and are, because there are major portions of the scientific community right now working on things that have no connection to experiments, completely detached, and will have no connection during their lifetime. And they feel that they are part of the scientific community. So that's a separate matter. But the actual objective of science is to learn about nature based on the evidence, based on experiments that guide us. So it's a learning experience. Now, some people expected maybe there is life on Venus in the clouds, definitely not on the surface of Venus because it's much too hot. There was a greenhouse effect and it's much too hot on the surface. It's closer to the sun than us. But there is a cloud deck where the temperature is similar to that in the lower atmosphere of Earth. And some astronomers reported on September 14th, 2020, that there is evidence for phosphine, which is a type of molecule that on Earth is produced by microbes. Mm-hmm. But first, this evidence is now not as robust as it used to be in terms of the statistical significance. So we need more data to be sure that indeed they detected something. Mm-hmm. But even if they detected, the question is phosphine necessarily indicative of life in the cloud deck of Venus? Because in principle, volcanic activity could produce it or something else. We have to figure out whether it's biological in origin or geological, for example. And that is work for the future. It's work in progress, so to speak. I don't have an opinion until we get more evidence. In science, it's not about prophecy. It's more about, given what we know, how likely. So at the moment, it's unclear, I would say, the situation. And most of the time doing science at the frontier, the situation is unclear. That's one thing that, I think it's a self-inflicted wound that the scientific community tries to portray to the public, that when it comes out with a statement, it's always certain, because a lot of scientists agree and they are sure of the outcome. But most of the time, scientists do not agree. The evidence is not conclusive. And I think a better approach, rather than pretending that the emperor has clothes, is to show that the emperor does not have clothes. That in fact, science is done by iterations. You have some evidence, you look at possible interpretations of that evidence, just like a detective story, and then you improve your understanding by getting more evidence, more data. Eventually, you conclude, with reasonable certainty what the conclusion is. And if the public were to see that process in motion, I think the public would get more confidence in science rather than less confidence. My colleagues are worried, if we show how much uncertainty we have during the process, and if we show that we make mistakes, then the public would never believe us that when we say there is global warming, for example. But the point of the matter is that, we should show whatever, we are doing, so that the public trusts the process. It's not science, the way I see it, is not an occupation of the elite. It's just a matter of applying common sense, given the evidence you have, and concluding what the evidence tells you. When I have a problem in my in a pipe or in a faucet at home, together with a plumber, we try to look at the clues and figure out where the problem originates from, and solve it. And I operate exactly the same way with a scientific anomaly or something that it doesn't really line up with what we expected. Try to figure out what it is. The same thing about Oumuamua or anything else. The problem is that if you have a taboo, for example, in the case of Oumuamua, not to discuss an alien technology at all, never, ever to mention these words, it's just like saying, okay, I'm doing a calculation, 1 + 1 = 2, and then someone comes and says, the number 2 is banned from any discussion. You should never mention the number 2, because it's never the number 2. And then you say, okay, what do? I have 1 + 1. So this is a very unnatural situation. To have a prejudice or put blinders, saying you can never get into a particular interpretation. That's inappropriate when you do science. Everything is possible, and you look at the evidence. Now, the other aspect of the, I would say, unhealthy culture, scientific culture, is that on many occasions, scientists converge without any evidence, without something to support their notions. So people talk about extra dimensions. People talk about string theory. People talk about the multiverse. People talk about supersymmetry. And all these concepts that I mentioned are, part of the mainstream discussion. And by that I mean that people can get honors, awards, recognition, positions, everything, by discussing these topics that have no experimental support whatsoever. So you have things that for some reason the scientific community converged around, when nature itself never gave us feedback to say, yes, this is the right direction. And at the same time, you have questions that the public is really curious about, and the scientific community has the technological means to address that question. For example, are we alone? Is there life elsewhere? Are we the sharpest cookie in the jar? Are we the smartest kid on the block? These are questions to which we can give answers given the current instruments that astronomers are developing, but there is no funding at a substantial level. Young people are discouraged from entering those interesting questions. And I ask myself, how is that possible? If the public is interested and the public funds science, and the scientists have the tools to address these questions, how do you get this unnatural situation? And just to give you a very specific example, in the next decade, astronomers are proposing to build telescopes or work towards observatories that will cost billions of dollars in search, for example, for oxygen in the atmospheres of planets around other stars. And the idea is that the oxygen will be a marker, a signature of microbial life, primitive life. Now, there are two problems with that. First of all, the Earth didn't have much oxygen in its atmosphere for 2 billion years, roughly half of its life. The first 2 billion years on Earth, there was no evidence in the composition of the atmosphere for oxygen that would indicate that we had microbial life on Earth. So you could have life with no oxygen not much oxygen in the atmosphere. The second problem is you can have oxygen but without life, because oxygen can be made by natural processes like breaking up of water molecules. So oxygen, even if you detect it after spending billions of dollars, it will not be a proof that life exists on those planets. Okay? What would be a proof? If you detect industrial pollution, for example. So these CFCs, these molecules produced by refrigerating systems or industries here on Earth, with the same instruments that are aiming to detect oxygen, you could also search for industrial pollution. It's just a change in the frame of thinking. It doesn't require extra funding, but that is never mentioned as a motivation for these instruments. And I think there is something unnatural in the way that the community thinks, because if we do find evidence for industrial pollution in the atmospheres of other planets, that would be conclusive. You can't make these complex molecules by natural processes. So oxygen will not be conclusive. Industrial pollution will be. What else do you need to motivate a big project other than something that is more conclusive? So, and it's considered as a fringe argument. I don't understand why.
No, it makes a lot of sense the way you describe it. One thing that I think is also taboo, I'm not sure on it myself, but we have all these, scientists, pilots, military personnel coming out saying that they've seen objects or seen some sort of proof that we're being visited by more than just Oumuamua. What are your thoughts on that? Is this something we should study seriously? And do you think there could be some truth to it?
Well, first of all, I should say that as a matter of national security, it's important to examine those reports, because you want to know if other nations are using technologies that we do not possess, right? So if there is something spying on us, you want to know about it, okay? So it's important to pay attention to it. But as to whether it's alien civilizations, I'm doubtful for a variety of reasons. First reason, I don't think we deserve attention. I think we are not very smart. If you open the morning newspaper every day, you realize, our civilization is doing a lot of stupid things, not really promoting its interests, wasting a lot of energy and money and so forth on destructive things, And so I don't think that we are, really the smartest kid on the block. There could be cakes that were baked to a much higher intelligence than we are. Out of the same chemical soup that existed on the early Earth. But the other, so then we are sort of, I would think that we are a middle of the road kind of creatures that you find in many places, and therefore, when you walk down a sidewalk and there are ants on the pavement, you don't pay special attention to every ant that you see, because these are common. So I think we are common. I don't think that we are special, unique, worthy of espionage. Okay, let's put. So that's reason number one. The second is that the cameras that were recording these fuzzy images of saucers or something else 50 years ago. By now we have much better cameras, much better recording equipment, instrumentation, and the evidence is still on the borderline of believability. It's still fuzzy. I would expect with present-day technology to see crisp images if the old reports were correct. So to me, that indicates that the fault is really with the instruments, that may be artifacts, that every generation of instruments has some artifacts, some illusions due to technical properties of the device, and perhaps that's what we always see. And another possibility is some natural process, that happens and is misinterpreted. But I do think that it's important for the scientific community to examine these reports. So in other words, suppose um, the military reports that over a particular region, over the ocean, you see some unusual phenomena. You can, in principle, fund a project, scientific project, where you take scientific instruments, place them around this region, and try to record whatever you see with much better sensitivity and precision and resolution and everything, and do a scientific experiment to check it. But if the scientific community is just dismissing these reports and there is no funding to check them, then we will stay in this vague situation where, the general public entertains this possibility and the scientific community completely ignores it. I think, it would make a lot of sense to just put some money. It may not require a lot of money to fund scientists that will collect data in the same environments where the reports find something unusual, and then we can close if the chapter. If there is nothing really found, we say scientists looked into it and nothing was there. But if something is found, then we have to explain it.
Interesting. Yeah, that makes sense. So we're coming down to the last few questions here, since we're pushing a bit for time. I read something interesting that Stephen Hawking actually visited your home. Wondering what that experience was like.
Yeah, so it all started, I attended an event back in 2015, and his caretaker, he was in the same hall at the Royal Society in London, England, and his caretaker said to me, Stephen is bored. Would you mind speaking with him, please? So I was the only physicist in that big hall next to him. So I went to him and said, Stephen, we are about to inaugurate within about a year or less than a year, a new center that we call the Black Hole Initiative, that will focus on the study of black holes. And since you worked all your life on black holes, we would like to have you as our special honorary guest. And then I left him because, it would take a few minutes for him to respond, and I was not that patient. So I thought that's it, but then a few months later, he wrote a special letter. He worked on it for a day, wrote a letter to his doctor asking to make the first international trip for him in about 3 or 4 years across the Atlantic, because he was not allowed for medical reasons. And the amazing thing is that the doctor approved it. And so a colleague of mine from the physics department at Harvard, Andy Strominger, came to my office and said, it's amazing, the doctor approves it. The only problem is it will cost $500,000, but that's your problem as director of the Black Hole Initiative. And he left. And I called the dean, and the dean said that, there is no way we can raise that amount of money, and there are risks involved because of his health situation. Bottom line is that I found funding for it within a few days then he came to visit in April 2016, and I hosted him at our home for Passover, because it was just at the time of Passover, and he liked the food that my wife made. He came with a whole crew of people that take care of him, including some, bodyguards or police security people. They were very helpful, because one of the guests that came to my house was careless, and she put a bottle of wine in a bag on the floor, and then the bottle broke, and the wine went onto the carpet. But these security guys were so skillful that within a few seconds, they immediately, cleaned it up. And so that was a great benefit to having them as well for dinner. And he gave a small speech at dinner, because during the same visit, we also inaugurated Starshot, which is a project to visit the nearest star, funded by Yuri Milner from Silicon Valley. And Stephen attended that public announcement in New York City, where I was as well, and then came to inaugurate the Black Hole Initiative on the same trip. And so overall, it was an amazing experience, in the sense that you could see him as a relatively modest and straightforward person. I mean, one of the evenings, he told his caretakers, he said, I'm pretty bored. Why don't we go to the bar of the hotel and have some fun over there? And he lived sort of life as not a person that doesn't have these disabilities. And the remarkable thing is, most people would get depressed under these circumstances without having the physical ability to do normal things, and he just ignored it.
Wow, that's pretty astounding. So yeah, I guess that's about it here. Your book comes out on the 26th, right? So it was interesting. I hope people check that out. Thanks again for coming on. It's been a pleasure.
Thank you for having me. I enjoyed very much the conversation.
Appreciate it.